Hey gang, welcome back to class. Appreciate all the nice comments you sent, and I am giving Bill Nye a run for his money. All right, I'd like to finish up chapter 21 with our electrochemistry section by a quick review of the redox reaction, reduction oxidation. As we talked about the batteries, the voltaic cells by Alessandro Volta. One particular battery would be a car battery. As we saw, the lead bonds with the sulfur dioxide and gives off that electricity, the electrons that the car uses to start it off. That's the oxidation part of the reaction. The oxidation reaction provides the electricity to start your car. The other half, the reverse of that reaction, the reduction reaction, the alternator of your car, once it's already running, inserts electricity, inserts these electrons into the battery, splitting it back in half, reducing it back to its original reactance, so that the battery is prepared to once again oxidize and provide additional electricity, additional electrons to start your car again, once it's been sitting. I'd like to move over into a process called electrolysis. Electrolysis is the other half of this oxidation reaction. Electrolysis is a reduction reaction. We are inserting electrons into the process. These electrons, these electricity, are being pushed into these reactants to cause them to recombine back into their original reactants. As opposed to the voltaic cell, like we said, was more based on the oxidation reaction. The electrolysis is based on the reduction half of that redox reaction. A couple good uses for this, as we're splitting our water, H2O, into hydrogen and oxygen. Well, obviously we have to first start by balancing the equation. So we're running an electric charge through a glass of water, and it separates it into hydrogen and oxygen. Great fuel source. There are cars today that run on fuel cells. Fuel cells are a collection of hydrogen compressed. Flammable, great fuel, very efficient cars with no pollution. No downside to these type of things. Another type of electrolysis is plating. In this case, silver plating, making jewelry. Makes it pretty, makes it last longer. The silver, we force the electrons, force the electricity into the process, and the silver coats the iron, and we have a silver-plated jewelry. We also have chrome that makes these different types of metal and steel last longer, prevents them from the iron from rusting, and takes care of them and makes them more effective, makes them more efficient, makes them a better product for our use. All of these different types of electrochemical reactions, redox reactions, as we've said before, almost all chemical reactions are redox reactions. They all involve moving these electrons from one half to the other. So if you have any questions on these things, feel free to watch these videos as many times as you want. And I am standing by my email waiting for your responses. Thank you, and I will see you next time.